Hi everybody. Today we are going to see the use of control charts in plan adjustments of geometry. Let's refresh some material about control charts. As you can remember, we have our mean, the mean of our process, of our characteristic, and then the upper control limit here and the lower control limit. These control limits are calculated from the value of the mean and are placed 3.3 or 3 standard deviations from the mean. The use of 3 or 3.3 is a decision that is based on how stable our process is. Then this picture represents the change in the geometry in our characteristic, the change of the value of our characteristics, the change in mean, of course. Then we have here the representation of the values of our original process, of our original value, and then when the change happens, here we have our hypothesis, that is, that all the points are placed outside the control limit that we originally had in this situation. Then, in this case, we would detect that the change has happened. That is what we would like to do. Here we have the first table. This table has two ranges of values. One represents in columns our original process. This is the range, the total range of our process. This value can be gathered from our historical data. And here we have the change we would like to detect, or the change of the characteristic that we have already panned, and of course we would like to detect as well. Then we enter in the table from columns, choosing the correct number from our historical data. Then imagine our process has a total range of 0.5. Then we would choose this column. Then here we have the change we have planned, or the change we want to detect in our process, and then we would choose this row as well, 0.5. And then we get this number, 1.818. If we had XS charts instead of XR charts, then we would use this table, but it is working in the same way. What I have to say is 0.1 is not equivalent to 0.5 in the example that we have seen before. Here we have the values we would get from the examples we have already seen. Then in the case of the example using XR, then the value, as you can remember, was 1.818, and then we would choose always the highest number that would give us a sample size of 3, and in the other example we would choose also the closest highest value, that this is this one. Then we would have a sample size of 2. These sample sizes, for example, in the case of X bar chart, says to us that in order to be able to detect this change, we would use a sample size of 3. Then, previously to the adjustment, we would like to produce 3 units without the change, and then 3 units with the hypothesized changed. Or this can use also to choose the correct size of the subgroups of the chart in order to detect this kind of adjustments or changes. For example, to prevent our process from being incapable to meet customer expectations, for example. Then we would be 99.9% of certainty that we would detect these kind of changes. In the case that the table would give us a number greater than 10, then we have to use always X bar S chart, because this is more appropriate to this sample size instead of XR chart. Of course, if you would like to read the complete study or would like to know more about this methodology, then don't hesitate to contact me, and I would send you further information and the complete study. This is all for today. Thank you for listening, and see you in the next presentation. Bye bye. Have a nice day.